Welcome, viewers. I am borrowing my husband's gaming headset to try and see if the sound is any better today. So let's go for it. All right, so we are on second video, Unit 1, Day 2. It's on the segment addition postulate, and that's exactly what it says, what it sounds like. Segments that we're going to add together. Now, a postulate is something we know it's true, but it's not a theorem. We haven't proven it, so we just assume that it's true. So we'll see lots of postulates and theorems this year. So I want you guys to see how these postulates and theorems are going to look in textbooks, because that's what it's going to look like in college, and you're just going to have to get used to it. So I've shown you in the notes here. This is what the postulates will look like in a textbook, and we'll look through it, and then I'm going to explain it to you what it actually really means. It's always a lot easier than what it looks. So, and sometimes you might have to read these things more than once. You got to get used to, pressing pause, reading it again, making sure you understand it. I'm trying to make the video short. If B is between A and C, then AB plus BC equals the entire length AC. That's it. It's just this plus this equals the entire length. So if this length was 3 and this length was 5, the entire length would be 8. That is it. Now, there are going to be unknowns in different places, and depending on the problem, you will have to add or subtract. Sometimes you'll have to set them equal and solve. There's going to be algebra involved, which is why we need to make sure you take Algebra 1 first so you can solve equations. Let's go to the example. Use the diagram to find KL. Now notice how there's no line over the top of KL. See that? It's just a KL. What that means is this is the measure of KL. So the measure of that line segment is an actual number, so you're going to have an answer. So JK plus KL should equal, well, I'm running out of, I'll draw that in yellow, JL. Now, if you don't have these notes printed, you could write this down on a piece of paper. You can draw your diagram. There's not a lot to write. You don't have to write all the words. Okay? So what are we going to do here? Let's substitute in the values we know. Well, we know that JK is 15. And we don't know KL, right? This distance is unknown. I'm going to put an X there. Okay? So I'm just going to write plus KL, don't know it, that's our unknown, equals, now they told us that JL is 38. So 38. Now you guys know how to solve this one-step equation from Algebra 1, and I want you to do it with me. Subtract 15 from both sides, and I want you guys to try not using a calculator. If you've got a, 4-function mini calculator on your phone or wherever you want to use that, that's fine, but you shouldn't be using it for pretty basic stuff like this, because I think you guys can do 8 minus 5 is 3, and 3 minus 2, or 3 minus 1 is 2, so 23. Then you have to rewrite, because they're asking you to find KL. You need to say KL equals 23. There's your answer. You circle it, you're done. Okay? Now, congruent segments are line segments that have the same length. Okay? So, what I was just explaining to you earlier, the difference between when there's a line over the top of AB and when there's no line, like this one. Okay? So, this means we're talking about AB is equal to CD. This measure is the same as this measure, and the measure of a segment is a number, so it's like 5. So you can say 5 equals 5. So this is a really important concept that we're going to use all year, and by the end of the year, most people still don't get it. Now, if you put a line over the top of it, this is a picture. It's a picture of a line segment. Pictures can't be equal. like triangles, a picture of a triangle can't be equal to another triangle, but it can be congruent. It can be the same shape and the same size. So if we're talking about the segments, we can say they're congruent, and this is the symbol for congruent. It's an equals with a squiggly. So if you write an equal sign, those better be numbers that you're setting equal to each other. A midpoint is a point that's directly in the middle. So if I drew a line segment and I put a point right here, and I called it the midpoint, usually the midpoint we use a capital M. What that means is that the lengths of these two segments are the same. They are congruent. And the way we show that is we put a little mark on it. That means those lengths are the same. So if you get a segment that looks like this, you're told this is the midpoint, and this length is 5, then this length also has to be 5. And a segment bisector, something that cuts this segment directly in half. Bisect. Bi means 2. Sect means cut. We're going to cut a segment in half. It could be a point, it could be a ray, it could be a line segment. Let me go to the next page and I'll show you an example. Okay, so in this example, we've got, let me see here, different color. Do you see these marks? What does that tell you? That tells you that those segments are congruent. They're the same length. So this ray here is bisecting the segment AB. It's cutting it right in half. So if this length AC is 2 1/4, that means the length for CB is also 2 1/4. So the length of, and then you have to be careful. What are they asking for? They're not asking for the length of CB. And this is a really common thing that we're going to do all year. We have to go back and read the problem and answer the question that they're asking, because sometimes they ask for different things in every problem. And here they're asking for the length of AB. So we're just going to add 2 1/4 and 2 1/4. So that's 4 1/2. And you can write 4 1/2 however you want. I'm just going to write AB equals 4 1/2. You can write 4.5. It is perfectly fine. If you write a fraction, just make sure you simplify it. Now, this one is interesting. I want you to pause and I want you to look at it and read it and then listen to what I have to say about it, okay? So point K is the midpoint of JL. It's right in the middle, okay? That means these lengths are the same. How do we show lengths are the same in an equation? Because we're going to have to write an equation to solve for this value of x, to show that they're equal or the same. And here's how you do it. 8 minus 3x equals 2x plus 5. So now we're going to solve just like we would in Algebra 1. And I'm assuming you guys know how to do this. A lot of times I won't show the steps, but I'm going to show you today and, for a little bit, but really want you to get, and I know it's been a while and, you missed part of the year last year. So I want to see you practicing, and you should be writing this out. These equations, do not do this in your head, okay? So, and you don't have to do it exactly the way I do it, but I'm choosing to move my x's to the right. And notice how I wrote plus 3x on both sides, and now those cancel. And now I'm going to rewrite what I have left. 8 equals 5x plus 5. Now I'm going to subtract 5 from both sides. And I am running out of room. So the way I want you to show your work as well. Oh shoot, what just happened? There's my little Pikachu. Okay, I'm going to put an arrow. So anyone that's watching this won't get confused where my work is going. And that's what I want you to do when you're doing your work. Just from now on, in any math class, a lot of people will do the next step here and the next step here. You need to consistently be working down and then move over somewhere else and work down again. Okay, now that we have 8 minus 5 is 3 equals 5x, we have to isolate that x. The x is currently being multiplied by 5. The opposite operation of multiplying by 5 is dividing by 5. Both sides, 5 divided by 5 is 1, so that's just 1x equals 3/5. Boom, you're done. Now let's read the problem again and make sure we answered the question. We haven't, they didn't. Sometimes they do ask for the value of x, and we would be done. But today we are not done because it says find the length of KL. KL in a different color is right here. So I'm going to write K. Oh, that's too light. I'm going to use blue. KL equals 2x plus 5. X is now 3/5. Okay, so what is that? How do you multiply 2 times 3/5? Well, that's the same thing as 2 over 1 times 3 over 5. You just multiply 2 times 3 and you get 6/5 and plus 5. Now, how do we add 6/5 and 5? 6/5 is the same thing as 5/5, which is 1 whole, plus an extra fifth. So 6/5 is, if I took a circle, oh my God, that's terrible, isn't it? Horrible. I should never teach art. All right, there's a circle with 5/5. All right, and then we have an extra fifth, right? So that's 6/5 is 1 whole and 1/5. So that's 1 and 1/5 plus 5. So that equals 6 and 1/5. And if you want to write it as, an improper fraction, that would be fine. They don't really care how you write your answers. So 6 times 5 is 30 plus 1 is 31/5. Whatever, either one of those. But the answer should be, and this is so messy, KL equals 6 and 1/5, or KL equals 31/5. I think we are finished. Oh, just want to show you one more thing. If you ever get a line here, and it's named some locations for you, they ask you to find AB. They're asking you to find the length of AB. Well, how long is that? It's just 1, 2. To go from 5 to 7 is 2. And what's the length of AC? Do it, press pause and try it. From 5 to 10, well, you can just do 10 minus 5. Or you can count 1, 2, 3, 4, 5. Boom, done. We are finished. See you in class. Don't forget to click like.